We are asked to solve the inequality 2x squared minus 3x minus 9 is less than 0. So we need to figure out what numbers we can plug in for x to make the left side less than 0. So first thing is you're going to solve this as if it was an equation. So you can use quadratic formula, or you could try to factor. So I'm going to try to factor. So I'm going to put my ax term in the front, and I'm going to multiply a and c, and that's negative 18, 2 times negative 9. And I'm thinking 6 times 3 is 18, but it has to make negative 18, and it has to add or subtract to negative 3. So if I make the 6 negative, that would work. So then I'm going to insert negative 6 and positive 3, and then I'm going to divide out the common factor here. All right, so again, I'm solving this as if it was an equation instead of this inequality. So now I'm going to set each factor equal to 0 and solve. So we would get 3 and negative 3/2. Okay, so then the next step after we have we call these boundary numbers, is we make our number line. So negative 3/2, or, that is the same thing as negative 1.5. And then we have 3. So now I need to pick a number that's in these 3 regions. So I'm going to pick a number that is less than negative 1.5. So for example, negative 2. And then I'm going to pick a number that's in between negative 1.5 and 3. So I could pick for example, 1. Okay. And then I could pick a number bigger than 3. So I'm going to pick 4. And I'm going to plug those numbers into the original inequality to see if they're solutions. If they are, then all the numbers in that region are solutions. Okay, so if I check the negative 2 first, I plug it in. Order of operations, I do my exponents first, so that's 4. And then after exponents, we multiply. So a 2 next to here means multiply. So I have 2 times 4, that's 8. And then negative 3 times negative 2, that's positive 6. And then bring down the negative 9. And then here we'd have 14 minus 9 is 5. And then we read that and see if it's true or false. Is 5 less than 0? No. So we are not going to shade on the left side of negative 1/2. They are not solutions. So now we're going to repeat this process and now check 1. Okay, so we plug in 1 and we get, is negative 10 less than 0? Yes. So that means that we are going to shade in between here. Now we have one more to check. Now we're going to check if now we let x be 4. Okay, so when we plug in 4, we get 11 less than 0. That is not true. So we don't shade there. Now, on our boundary numbers, we need either parentheses or brackets. So if we go back to the original problem here, since there's no line underneath, since this is not a greater than or less than or equal to, doesn't have the line underneath, then that is why we're going to have parentheses, because the numbers that these parentheses are on, the 3 and the negative 3/2, are not numbers that we can plug into this original problem here and make the left less than 0. So what our answer would be x can be any number in between negative 3/2 and 3.